Hello everyone, welcome to Mariner's Point. Here we are going to solve electrical written numerical questions which is asked in MU class 4 in the written exam. We can see question on the screen. A 500 volt 3 phase a star connected alternator supplies a star connected induction motor which develops 45 kilowatt. The efficiency of the motor is 88% and the power factor is 0.9 in lagging. The efficiency of the alternator at this node is 80%. We have to calculate the line current power output of the alternator, the output power of the prime mover. First, I will write the data which are given in the question. Mechanical output, which is given 45 kilowatt. Motor efficiency is 0.88. Motor power factor is given 0.9 in lagging. Supply, which is 3 phase, you can see line voltage 500 volt which is connected in a star. Alternator efficiency is 0.8. These are the data given in the question. Now we have to calculate line current. I will calculate? First, electrical input power to the motor. For that we will use efficiency formula. Efficiency is equal to power output divided by power input. Okay, so input power will be is equal to power output divided by efficiency. So here power input is equal to how it comes, how this expression came. I show you. So power input which is equal to output power, mechanical power divided by efficiency. So it will comes this one 45,000 divided by 0.88. It will come this one. Now we will use power factor formula. So rating is equal to power factor is equal to power input divided by power rating. So this is called apparent power, that is rating power. So rating power is equal to, using power factor we will calculate power factor. We calculated power input mechanical. Using this we will calculate apparent power. Power input mechanical divided by power factor, it will comes apparent power. Now in line current using rating or apparent power we will calculate. Apparent power is equal to root 3 line voltage and current voltage. Using this formula, we will calculate line voltage. So here we calculate line voltage. For calculating line voltage, we will use apparent power formula like this. Apparent power is equal to root 3 VL IL. For that, we have to calculate apparent power. Using power factor formula, we will calculate apparent power, and for calculating apparent power we have to calculate input power calculated by efficiency formula. So first use we will, it is given efficiency is given, power factor is given. Why it is given? There is some sense. So using efficiency formula, then power factor formula, we calculated apparent power, and then using power in line current we will calculate. Now power output of the alternator. Power is simple. The alternator must supply the motor's electrical input, so electrical output is equal to electrical sorry, power input. So this one is equal to, we already calculated power input mechanical. Next, output power of the prime mover. For that, we will use alternator efficiency, power alternator, which is output divided by P primer. Primer moving is giving input power. So prime mover power we will calculate by using this formula. So output power of the prime mover we will calculate like this.